page 5 in the white packet for 4.3, we're going to do try it 2a at the bottom. Factor the top and factor the bottom. I'll pause and we'll see how you did. Okay, so we completely factored the numerator and we partially factored the denominator, but we're not done because what is highlighted can be factored a little bit further. So we're going to leave the top, x plus 1 times x plus 1. And on the bottom, we're going to factor that highlighted piece into x minus 3 and x plus 1. Everybody agree with that? Yes? Yes? Agreement? Good. So we are factored completely on the top and bottom. We're going to reduce this fraction by looking for anything that the top and bottom has in common. I see an x plus 1 up top and an x plus 1 on the bottom, so those can cancel. Right away, when something cancels, we know that that's where the hole would occur. We had our notes on the board yesterday. You either have a hole in the graph, a vertical asymptote, or an x-intercept. There are 3 ways it can happen. The hole occurs at -1, comma something. We'll come back to the y value in a moment. Okay? In the denominator, we still have 2 factors that did not cancel, and that's where our vertical asymptotes will be. So there will be 2 vertical asymptotes. One at 3, because 3 minus 3 makes 0, and you can't divide by 0. Okay? And the other one, when you have a lonely x all by itself, the other asymptote is at 0. So 2 vertical asymptotes at 3 and 0. Second to last step would be any x-intercepts that the graph might have. Sort of an important piece when you're going to graph something. You want to know either where its y-intercept is or where its x-intercept is. The x-intercept occurs when the numerator zeroes out. At the value that you would plug in to the numerator to create 0. Whoops. And I think it's going to be at -1. Okay? If I put -1 in up here, wouldn't it create 0 in that parentheses? So that's your x-intercept. -1, 0. Now, if you're wondering how we find the y-coordinate of the hole in the graph, here's what we do. We look at what the function looks like when everything has been canceled. And you plug in -1, because that was the x value for the hole. But we already did that. We already know what the y-coordinate of the hole is. It's going to be 0. So in this problem, it's just a coincidence that the hole in the graph is also the x-intercept of the graph. So technically, I guess this function wouldn't really have an x-intercept. That's the point at which the graph would just skip over. Okay?